Now it's time to further investigate logarithmic functions, and the way we can do that is by looking at the graph of a logarithmic function. And to get there, we want to remember that we have exponential functions and how they relate to logarithms. So our goal with this first example is to graph these two functions and see something. I'm not gonna spoil the story, but let's see something on the graph. Okay, so first of all, to graph f, right, we know how to do that. We can just do x, and then I'm gonna do 2 to the x, which is y, right? And so maybe previously we did -2, -1, 0, 1, and 2, and then substitute that in, and this one you get 1, and then 2 and 4, and here you get 1/2 and 1/4. Okay, and we can certainly plot that, and I'm going to do that in blue. Okay, so we have 1 0 or 0 1, we have 1 2 2 4, and then -1 1/2, and then 1/4, and I'd get something that looks kind of like this if I can hit the points. There we go. So this would be f of x. F of x. Okay. Now, to get the logarithm graph, that could be a little tricky. So we want to do x and then log base 2 of x. Okay, certainly you could pick numbers, but then how do you calculate the y value? I don't know, but here's what I can remember. These two are inverses. So inverses, right? So if I want to graph log base 2 of x, all I have to do is switch the x's and y's. So these x values become the y values, and similarly, the y values become the x values. So the coordinates that I would have, so I'm just going to write these 1/4, 1/2, and then 1, 2, and 4. And then for the y values, that would be the x values from the exponential, so -2, -1, 0, 1, and 2. And so I have, let's put this in green. So I'd have the point 1/4, -2, so something like that. 1/2, -1, 1, 0, 2, 1, and 4, 2. So I get something like that. Okay, and so remember, for inverse functions, we should see it exactly mirror, and I'm going to do my best to draw a horizontal or a diagonal line here. We should see it mirror right across this line, y is equal to x. Okay, and so here's the function g of x, which would be the log base 2 of x. Okay, so a neat way to graph a logarithm is to start with the graph of the exponential and reflect it over the line y equals x, or just switch the x and y values. Okay, there we go. Now, we're not going to do this due to time, but remember that if b was greater than 1 for your logarithmic function, we said this would be the case where it's increasing, and then this would be the case where it's decreasing. And so if we're thinking about long-term behavior, we're thinking about what happens to x as it goes off to infinity. We can't go to negative infinity, right, because we have an asymptote, right? X goes to infinity. What happens to each of the y values? So we'd have f of x in this case where b is greater than 1 going off to infinity because it would continue to increase. The y value would get larger in value positively. And then in the case where b is a fraction between 0 and 1, we'd actually see it going to minus infinity, so it would become a larger negative number. Okay. Also, in the case, so here in this example graph, we had log base 2, so it was a value b is greater than 1, and we see it's increasing for sure, but then we can think about concavity. And so in the case where b is greater than 1, which is like what we have here, we could say that it is concave down. Okay. Down, man, I can almost write today. The concave down. Okay, it's bending. Its bowl shape is kind of down. It's looking like a hat that you could put on your head, and it'll actually turn out that if the b value is between 0 and 1, you get that it's concave up. So kind of opposite of what we might expect, but it makes sense with the graphs. Okay, so that's the basic idea with exponential and log functions in their graphs. But now, of course, we can transform these, right? And so we have f of x is equal to 2 times log base 2 of 3 minus x. Okay, determine its domain, range, and any asymptotes. So, okay, first of all, what is going on here? Okay, I just need to write this out. So we have f of x is equal to 2 times log base 2. And then I'm going to interchange the roles here. I'm going to write this as negative x plus 3, just swapping it around so I can see, my a, b, and c, and d in the function a little bit more easily. Okay, and so if I compare to my general transformation model, I can say, oh, okay, like now a is 2, b is going to be the negative on there, and then c is going to be the 3. Well, minus 3, right? So I can more easily identify the transformations. Okay, before I go that far, I want to talk about domain of f. I want to talk about range of f, and then I want to talk about asymptotes. And here, I'm only going to have a vertical asymptote since I'm dealing with a logarithmic function. So domain, okay? Remember that to find the domain, I could take the expression inside the logarithm. I guess I don't need parentheses. And I can set it greater than 0, okay? So I'd have negative x is greater than negative 3, and then divide both sides by a negative, which would reverse the inequality. So x is, I'm just going to do little arrows here. X would be less than 3. So then my domain is just negative infinity to negative 3, or to positive 3, sorry. Okay, now in this case, we have negative numbers, but it's just because of the transformation that the logarithm has had done to it. Okay, this also means that the vertical asymptote is the boundary of our domain. So vertical asymptote is going to be at x is equal to 3. And the range for every logarithm, no matter what you see, is always going to be all real numbers, all negative infinity to infinity. Okay, so now, how do I graph this function? Okay, what I'm going to do is remember my transformations. Okay, so I'm going to start with log base 2 of x. Okay, and then I have to remember CBAD, right? I do CBAD. So then I'm going to go from here, go to log base 2 of x plus 3. And then, so that's a horizontal shift to the left by 3 units. And then log base 2 of negative x, so this is the b. And then the last step would be to incorporate the 2 in front, 2 log base 2 of negative x plus 3, okay? But to start with this one, right, I might want to look at that graph of 2 to the x. And we actually already did that, okay? I'm not going to graph this, but from our previous example, we have what x and log base 2 of x, that table should look like. And so I'm going to plot that in green here. I'll do that in green. So it was 1/4, negative 2, and then there, there, and there, okay? So this is log base 2 of x, okay? And then I'm going to go quickly through the transformations to save time. Shift to the left 3, so 1, 2, 3, and then I'm just going to shift all the left points to the left 3 units, something like that. And we have that, and we have that. Okay, so this is what I've done in blue. Next, I'm going to do red, which is the horizontal scaling by -1 or horizontal reflection. So this would go there, that go there, there, and then there and there. Okay, so that's in red. And the last one is just going to do the vertical scaling. So that's multiplying the y value by 2. So do here to up there to there, and that doesn't move. That actually comes down, and this comes down as well. So my final graph looks a bit of a mess, but that would be the final function f of x. Okay, and if you don't have colors, again, labels in as much as possible. Okay. And certainly feel free to check this with decimals too. Always feel free to use your resources. Check your answer, not produce your answer. But point of all this is to get the graph of a logarithm, right? Consider the associated exponential form, develop the table from your exponential form as we did up here, and then switch the x and y coordinates, and then you can transform it as need be, all right? We'll see some more practice in person.